Okay, hi, welcome folks. My name is Bob, call sign W06W, and I'd like to introduce my good friend Chris Rutkowski, NW6V. Chris is one of my primary mentors on the use of a straight key. He has an excellent fist and has thought long and hard about what makes Morse what it is. This will be the first of a three-part series, and with that, Chris, on to you.
Hi, everybody. Welcome to the shack. Thank you for coming down today. Really glad you could make it. It's not a beautiful day in Lake Wobegon here today. It's rainy and cloudy and nasty and cold outside, but it's sunny inside because of all the lights. Hopefully you'll find this little presentation interesting and of use as we go forward. So let me get started with it without further ado. Hopefully you all can see that screen. Keymanship is about Morse, you, and the key. There's three parts to it. And so the series has three parts, the beat and rhythms. And then there's perception and experience. And perception and experience, I always say, this is your brain on Morse, taking the old line. And the third part is code talking and straight key basics. And code talking, I think, is the first key people should learn to use because it ties directly to the other things. The goal for this week is to talk about the underlying beat and rhythms of Morse and to show you how the code and key are connected and how they connect inside you. And we're going to discuss principles that help create perfect code. And that's everybody's goal. And when I say perfect, I mean perfect is not a canned thing. Perfect is a very broad thing. And when you get good at it, you stop worrying about whether it's perfect or not. It just works. But first, I'm going to give you a little disclaimer, by the way, for anybody who wants to try some of these things. Operating a manual human interface device, such as a mouse or something, is a mildly dangerous thing to do. There are risks attendant to any human interface device, operating a keyboard, operating a mouse, and yes, operating a Morse code key. So if it hurts, stop. If a doctor says don't do it, stop. If common sense says, well, this is ridiculous, stop. There's nothing here which is a catechism cast in stone that has to be done. And if you already use a straight key, go slow about trying any of the changes that you might pick up out of these seminars as we go along. You've got to pay attention to those first three rules and not do yourself harm. Anyway, we're going to start the talk with just throwing a couple of dots and lines up on the screen, dots and lines as Morse used to call them back in the day. And we're going to go from there and give them some amplitude, extend them a little bit for a better visual signal to noise ratio. And this is actually an interesting thing to take a look at. The dots and lines here are no longer dots and lines, are now squares and something. But if I go back, just notice the fact that there is actually a signal to noise ratio difference when the signals occupy a larger percentage of a perceptual field, in this case vision. That's the way perception works, and we're going to talk about that a lot in part 2 of this. Anyway, take those things and let's put a graph behind them with time on the x-axis so we can do some measurements. And then using the dit as our unit of measurement, we can see that the 1 unit between signals, a dit equals a single unit on this scale. There's 3 units between letters, etc. If you've studied Morse code long at all, you've undoubtedly heard about the 3-to-1 ratio between dits and dahs. And that's certainly a correct technical thing. And this shows actually that our little graph up here matches that 3-to-1 ratio for international standards. So what you're looking at, those drawings accurately reflect the real ratios. You're going to see and hear about those ratios a lot as you go through Morse code learning. You see it on every chart that you come along. This one, the top chart on here, the top of the 2 charts, is from Wikipedia, and the one on the bottom is from a fellow named K4ICY is his call, and it's also used by the LICW in their guide. And these are both, of course, technically correct. There's nothing wrong with them at all. And these show what the code is, but they don't show you how it's made. So let's take a different look at how all this works. Let's go back to a blank graph and draw a sinusoidal curve here so we can compare the dimensions of these things that we have. Let's compare all the marks and spaces that we're dealing with. So imagine a basketball. If you bounce it down toward the ground, you push it down, it hits the ground, it deforms a little bit, takes that energy, bounces back at you, controlled by the hand, and you can go dump, bump, 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 and bounce the ball up and down repetitively. That kind of repetitive motion is very much like what happens with a straight key. In fact, it borders on identical. Imagine a hand pushing down on a Morse key lever. When the contacts touch, the muscles in the key absorb the momentum, then rebound, opening the contacts. That's what it says on the screen. Once they stop, the momentum is taken up by that moving lever. It bends a little bit, and the hand's muscle bends a little bit. The springs in your arm and in your hand are crucial parts of absorbing the momentum of this motion. Everything above the center line in this graph is actual motion. I mean, everything in these parts up here above the center line is where the key and the hand are actually moving, and everything below the center line is where momentum is being stored, either being stored in your arm or in the parts of the key, in the spring of the key, that sort of thing. And I call these up and down motions key cycles. Key cycles are the units of motion of the hand and the key. And that concept of units of motion, of note down in the lower left, 1 key cycle equals 2 dit units. That makes some real differences in terms of what we see as we go along. The hand doesn't move 1 dit at a time. The hand moves 1 key cycle at a time. That's what's happening when you're keying. You move in key cycles, not in half key cycles, which is what dits are. So they're like the background beat, like music. If the conductor goes 1, 2, 1, 2, 3, 4, you don't hear him keeping going 1, 2, 3, 4, 1, 2, 3, 4, unless if he's a metronome. But it's in the background. It never ceases for everybody who's playing the music and really everybody who's listening to it. You all get on that beat. So that's a very important aspect of anything where you've got beats going on. And the demo, I'm going to show you a side view here of this as we go along. Let's see if I can show that. The idea that we have is that balanced up-down key cycles are what make perfect dits. My arm is vibrating up and down. It's not, I'm not moving it down and moving it up or moving it down and letting go of the key and letting the key finish it. It's a regular cycle going on. That's how you make perfect dits. Because each one of these is a half cycle. Each one of these marks up here shows what a perfect dit would look like on this graph. That virtual beat behind it is called the dit-train. That imaginary flow is called the dit-train because it's cute, but it's also technically appropriate. In datacom, we speak of packet trains, collections of bits bundled together end to end. And ironically, by the way, Morse invented the telegraph on board a packet boat. Packet boats were boats that carried mail packages back and forth between England and America and between France and America. They were called packet boats, and that's where Morse code was invented. So that could very well have been part of his inspiration, seeing these messages going back and forth. He was right in the middle of it. Entrainment is something we also hear about in psychology and in music, musicians playing together, just getting in sync with each other completely, or dancers. They become entrained in a single flow, and that's a great feeling. That's one of the reasons people do it. Everything is timed against the dit-train in Morse. It's just that simple. The dit-train is the middle of your Morse experience. Anyway, now let's go back to a blank key cycle graph, and we're going to superimpose those perfect dits. We're going to take a look and put those dits we drew back on top of it. These are the ones that we measured out. These are 3 to 1. And right away, we have a problem. If you may note, if you take a look at the graph, over here where it says whoops, what we're seeing is this, the dotted line is showing that the key is supposed to be up at that point in time, but the signal is on and the key Can't be up while the signal is on. That's an illegal condition, obviously. The solution is actually pretty easy. In this context, we're just going to slide everything a quarter of a key cycle to the right. And now kind of notice that magically, all of a sudden, you've got a perfectly aligned system. The signals are never on when the key is up, and except for pesky dahs, well, we'll get into that in a minute, but the key is never on when the key is up, and the key is never off when the key is down, other than that pesky dah. So we'll talk about that more in a later, but meanwhile, the next question for me is this a coincidence? And I don't think so. As I say in my book about Friedrich Gerke, the fellow who invented this code, he was a musician and a linguist and developed this for the German post office. And musicians know about beats, and they know about timing, and they know about chords and those things, which of these things have relationships. So I don't think there's anything coincidental about the fact that these things line up so nicely. I think it was intentional. So anyway, traditional charts show us what the code is. It shows you the 3-to-1 ratio. It's very nice, very accurate, very correct. But, oh, by the way, just something to mention as a word. We're using the word Paris. You may notice I've got that written across. I use it because Paris is the reference word in Morse code. When people talk about words per minute, what they mean is something equivalent in the exact length of the word Paris, of how many spaces it takes to make up and send that word. And that's what this table is showing. It's showing here's the word Paris laid out as dits and dahs with all the correct legitimate spacings between and after. And that 50 dit space length there, that's the standard thing you get with a 3-to-1 ratio. But now let's take a look at it from a different perspective. Let's look at it again now with key cycles. When you put key cycles up and get a chance to take a look at the code graph, what you see is a very different picture. What you see now is that all of the signals and all the spaces between them are all aligned with key cycles, with the up and down motions of the key. Again, accident? I don't think so. But certainly that is exactly the way the code is actually laid out. That's not nice. But anyway, being able to look at it in this fashion, to me, is very revealing. I think if you dissect this, there's a lot to be derived from it. For reference, I'll put a copy of this chart up as a PDF on MorseBusters.com so people can download it and take a look at the chart and ponder it to the degree that they will. But meanwhile, we're going to jump over and we're going to dissect it ourselves and ponder it a little more than we have at this point in time and see how these things work. You can do this on your own, by the way, given what we've covered so far. And those of you who've been in the code for a long time probably know most of this stuff already. You've known it just because it is, in fact, what you're doing. There's nothing here that I'm inventing, something that we're doing. These are the things we actually do every day. But let me take you to a couple of observations that are worth thinking about. Well, again, back to the dit-train, continuous virtual dits is the beat of Morse. Everything flows to that beat. It's like with music. Even when the music stops, the beat goes on in your head. That's the way it works. A single dit is made by a single key cycle, which is a very interesting thing. If you take a look at this graph, you can see that on the left, the first part of the dit cycle, the momentum is being stored, and then at the bottom of the cycle, the momentum is released and bounces back up. A couple of interesting things that I'll mention over and over again is the fact that in this cycle, a single dit key cycle, it contains a down and an up. And all key cycles begin by going down and end by going up. Why? Well, of course, the key starts with, you're not touching it. The key is there not making any noise. You reach your hand over and go, and it makes noise. So it includes not just the signal, but the time before and after the signal are part of the dit. That's kind of the way I look at it. That's the way I think you should look at it. And you'll perhaps realize that or accept that after you've gone through this a little bit. But the time before and after things are part of the cycle, the key cycle. Remember, the cycle starts before the signal, and it always continues after it finishes. So the end of each signal connects to the start of the next. It's actually a very interesting factoid that when you're up here, when the key is at the top position, after finishing making a signal and it comes up to the top, that puts it in exactly the correct position to start the next signal. That's where it has to be. It really is a very simple system. Now, there are no pauses in signal groups, and that's part of why showing that there are these spaces at the end and the beginning is important. Each key cycle starts with the key cycle that occurred before it. And again, that if we take a look at the side view on that, if I'm going da 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 da, the hand never really stops moving. If I'm going making continuous dits, it is a continuous motion that's occurring, and continuous motions are what makes smooth sending. And dits turn into dahs when you start damping them. A dah starts exactly like a dit, but that up momentum rebound is damped, it's constrained for a single key cycle. And by the simplest observation, this actually makes this beautiful relationship that we see here, and that is that 2 key cycles equal 1 dah of perfect length. I think Gerke certainly knew this, because maintaining these kinds of relationships is exactly what a percussionist does. And again, he was a musician, so I don't see how he would not have seen this as musical problems. And one of the nicest parts of it is that those 2 key cycles make a dah automatically. I mean, think about that. All the effort that people go to trying to get their dits and dahs right, that 3-to-1 ratio right, when the secret to it is just the dah is 2 cycles of the key and the dit is a single one. Now we can approach that. These are things that we can tear apart and learn on better. But the good news is you don't have to measure these lengths. You get back up in time. The secret to it really is that the last up at the end of the 3 over there has to be started at exactly the right time in order again to get you back to the beginning of the next character. So in the case of a dah, you don't automatically bounce back up. It's just held and you bounce back up the next time it should bounce up. And that actually has a feeling to it, which is one of the most important parts of this. And that's where we get into the subject of rhythms. 1 key cycle makes a dit, 2 a dah. And both individual signals are bounded by downs and ups. An interesting observation, by the way. That both, here you have a set, we're looking at a single dit and a dah, and notice that that set, the dit and the dah, begins with an up, rather begins with a down and ends with an up, exactly like a single signal does. Single signals begin with a down and end with an up. Everything begins with a down and ends with an up. That's kind of the universal rule in Morse. And by the way, if you're using a bug, the up is sideways, and these things rotate in space. Up and down are only relative, but the same rules of how you do motion, they occur in all the planes of reference. So this really does apply to every key. So the signals roll along in groups. They're like cars on the train. They're each separate from the other. Each group of dits and dahs is a discrete entity and really needs to be looked at like that, that it is a separate thing existing. People who are practicing ICR would say dit on that first letter there, the letter P. Hopefully I'm not giving away any secrets that these actually mean something as letters. But that thing is an individual little block. It exists as an independent entity. When you're making it, you go dit. It's a single boom of sound. That's the rhythm that people want you to connect to, is that single sound unit. You're going to be told that over and over again in your Morse learning. Listen for the sounds. Well, the sound that they're telling you to listen to are these sets of dits and dahs. And it's really interesting that they are connected end to end like cars on a train by, as we know, they're connected by a single key cycle between each one. Again, a perfectly rhythmic system. And that's where the answer to how you make dahs lies, really. Just one of the interesting facts about a 2-to-1 ratio of key cycles is that you're dealing with double time and single time. If you have one frequency being twice that of another, it is called having been doubled. And double time is very familiar as a rhythm that humans work with all the time. It's really easy. You can count it out pretty quick. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's a 2-to-1 rhythm. That's double time. It's like if you're marching. Bump, 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 bump. Da, 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 da. Do it in exercising too. You're doing double time steps and everything to get your exercise up. And on a Morse key, you can practice the same thing. Da, 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 and that is the rhythm of Morse code. Listen, I can play a little game with it. Da, 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 da. Those are Morse characters. And then da, 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 da. They're done at that exact same pace. The dits and the dahs are always in that beautiful 2-to-1 ratio of doubling. And that opens up a lot of doors on how you create nice, even dahs and beautiful dahs and really regular dits. And hopefully you'll see that. So anyway, let's continue on. And words are sets of letters. And they're separated. This is a bunch of letters here. And they are separated when you have a set of letters, which is a word. They're separated by 3 key cycles. That's how it works. And I'll just show you an interesting side point of that may not be obvious. Here over on this graph, if you may remember that back in the definition, or maybe I didn't show it to you, so how could you remember it? But back in the definition of Paris, it's 50 units long. And they always show 7 as the number of units between words. And I'm not showing it as 7, I'm showing it as 3 key cycles. Well, just if you take a look and see how that works, notice that this last dit in the word here has this little hanging bit of time at the end of it. And if there were a word following, it would be like this, and that character would have that extra little bit of time right at the beginning of it. And that extra makes up to 7. That's where the 7-dit separation comes from. I would say that one of the side effects of this is that if you things like Farnsworthing can really break understanding where you're separating the characters further apart at a random distance, breaks the flow. And you don't want to practice it all the time, because then you'll never be able to have good flow. It will interfere with you. If you're going to go longer and increase the space between things, make it in an even cycle. Add not 3 cycles, add 4 cycles between them. And the way you're going to know that that's happening is that the code is all going to flow, because if you add 4 cycles here, everything else would still fall right on the same dit train. You wouldn't fall off the dit train by adding an extra cycle. If you add an extra cycle, then now it's going to have a little bit of a jerk in it when you make that change. And one little jerk, it won't hurt anything. But if they're happening constantly and between every letter, if you don't have this accurate spacing between every letter and every word, you get an awful lot of junk thrown in. It makes it very hard to comprehend what's going on. We'll talk about that comprehension in the next section, by the way. In part 2 is where we talk about perception and experience, the experience of Morse. Anyway, to repeat my basic fun rule here, the up is just as important as the down. And I say that again, if you take a look at this little graph, I've got red lines going down and green lines going up. A key cycle is a balanced up and down motion. You can't make a down motion without an attendant up motion. The ups are important. They're important because if you want to get back to the beginning where you have to be up to start the next character, you've got to get that up done, which means they've got to be done with alacrity. They've got to be done cleanly and without a waste of time. So a good crisp motion is really the best way to make these characters, rather than kind of half and done. Regularity creates perfect spacing. That's the answer to it. Getting on the dit train is the key to all of this. When your code is on the dit train, you'll find that, quote, perfect, unquote, code is easier than imperfect code, because it'll be flowing and you can be in sync with it moving along. It's a lovely thing. The total rebound of the momentum opens the contacts, by the way, not just the return spring. This is something I like to demonstrate to people because beginners get an awful lot of angst about, oh, how should I set my key up? How big should the gaps be? And how hard should the spring be? And I see people recommending spring settings that are pretty hard. Sometimes, in fact, some of the setting recommendations are much harder than I would like to use for more than a few minutes. I can send on anything. I could send with really heavy settings and really wide spacings and all of that. It's not an issue. But one of the, again, something else that's kind of interesting to demo is the fact that I can send, I don't need to have any, I don't need to have spring tension at all. I can't lower it to 0. I can't lower the spring tension enough on the J38. It doesn't go down to 0. But the key behind it, this Chinese key back here, I can lower the spring tension to 0 by unscrewing this thing here. And now the key is, if I let go of the key, it's down. It's down on the desk. Not a desirable thing. But nonetheless, I let go of it and it falls down. You see, the whole point is that the key's spring coming up has nothing to do with my fist. It has nothing to do with whether I have a good fist or not. It just keeps the key up and it becomes part of this vibrating system, and my brain accommodates for it. So I can have a 2-pound push there. That's tough, like one of the new car horns where you got to put really on them. But I can use anything from a car horn to just pounding a couple of wires together. And to give you another example, if we come back here, if I just take my hand, and tap on the desk, where's the spring? There's no spring at all. No spring is needed. The spring, of course, is right here in my arm. The springs in my arm are the ones that are making it go up and down. And that's really a key takeaway. So don't get too worried about what the settings are. Change them, set them, use it for a while. If it doesn't feel right, change it again. If I were in heavy, I like very light settings, by the way. You may gather that I don't need them to be high, and so I keep them very light. But if I were operating on a ship, and things were heavy, or in a car or something like that, I'd have much heavier settings available in it because you don't want inadvertent motion of the hand to set things off either. So there are definite reasons to have higher settings. Also, a lot of people, there are techniques. We'll get into this in part 3 in techniques, but a lot of people use sending techniques where they were recommended to lay their arm on the table and sort of lay the whole thing down, and the hand is sort of laying there like a dead fish, and they got their hand up on it. And I think in a lot of cases like that, they are letting the key keep the hand up, as opposed to having the hand come all the way down. I think that's a pretty common thing. But again, we'll get to that in part 3. We'll cover all that in a great deal more detail. In fact, a great deal of detail. Hopefully enough detail. All right. So anyway, the up positions the key for the next down, and that's what you're trying to accomplish. If I do a side view on this, that again is that same side view shows the same thing. That again, I'm up here. The key starts, and to describe this, I describe it as being at attention. My hand position, again, I'm not laying the hand on the key. The hand is not pressing down on the key at all. I'm holding it up. I could probably do this for almost days. The hand, no effort is being exerted to hold it up. It's just an at ease, at position and attention. And then each signal goes up and down, and the end of the signal, the end, the up, is just as important as the down. It's really required to do that up at the end because it puts you in the right position to be able to go. You may notice that my key, when it goes down, is going, there's a dit on the upside of this. It makes a little click. I like that. I don't look for a really quiet key. Why? Because that up is the trigger for the next down. And all that becomes part of the timing, like the metronome that's going on in your head. And you'll learn that automatically as you continue to use things. The signals are connected by continuous motion. That's when you see my arm going up and down like that. There are no pauses ever inside a letter. Letters flow from symbol to symbol to symbol to symbol, and then there's a skipped bit, and then symbol to symbol, and a skipped bit, and a symbol to symbol to symbol. It goes together very regularly and very orderly, and it flows. It's a very important aspect of what you're trying to achieve. All of these details are there to point us in the direction of clean keying. Unlike music, Morse is inherently two-way. That's one of the key things we're trying to get across. And when you have Morse that's synced to the dit-train establishes the beat and rhythm so that, as with music, people that you're communicating with can get together and ride on the same dit-train. So that people are going back and forth, and information and messages and content can flow back and forth most easily. If I'm sending, this is why, aligning speeds, getting people, I'll change my sending speed to match your sending speed. Why? Because we both get on the same dit-train, it all flows easier. That's, again, one of those truths of Morse code that you'll run into as you proceed down this. So the good fist isn't for you, it's for the other person. A good fist creates expectations of what's coming next. Predictability, regularity, consistency, perfect rhythms. When you create those conditions, the other person can experience it at the same time. And that really is the purpose of doing this. Everything is tied to key cycles. They are your tickets to ride on the dit-train. And the dit-train is how information gets moved. Okay, so that concludes part one. Thank you for watching. I can't hear anybody, so I don't know if anybody can hear me. It's all very quiet here. And I can't see anybody either. Oh, did anybody stay? Hey, look, a couple of people stayed. That's fantastic.
That was very good, Chris. Very, very good.
I hear some fan out there applauding. That's always appreciated.
Yeah.
Throw money. Always throwing money is excellent. Excellent. I approve of that.
Where to?
All right, then. Any questions? Does anybody want to ask anything? This is your big chance to tell me to go away.
Chris, I have a question, or kind of more what I'm wondering about. I'm thinking about some of those studies about whether it be like empathy or like a flow state between two people, and kind of wondering how this would kind of map onto that. Do you know what I mean in terms of when two people are listening, they're on the dit train together? Like, how does that work? I guess almost like synergistically, maybe? Does that make sense?
Exactly. It is very much like dancing. Or like being in a musical group. If you're playing with other people at the same time and you're all going together, that is that exact kind of entrainment, I think, that you're talking about, is exactly the phenomena. So I see it tying in perfectly. That's exactly what's going on. This is how flow occurs. We tend to forget sometimes, since we're running classes in schools, that the purpose of Morse code is to communicate to another person. And that there's somebody else on the other side of the reception point, and that the job is to get it across to them. And then for them to get it across to you. And when you start working with the computer all the time, when people spend all their time drilling on computers, they lose sight of the fact, because the computer's going at them and at them and at them and at them, trying to teach them something. They forget that there's a two-way flow. That's an integral part of what we're doing in Morse code. And,
about the shared experience. Yes.
Yeah, it's definitely a shared experience. I say that it's almost like mind reading, like telepathy.
I was just thinking about that, about telepathy. Yes. I would be so curious to see what it would look like under an fMRI as well, with two people together doing that.
I would as well, and I'm sorry that Tom Pereira didn't make it here tonight. Tom is my favorite neuroscientist, and he and I have collaborated a lot on developing some of the things that I'll be going over in these presentations. But that idea that the brain is alive with this stuff is very near and dear to my heart. I get excited by it.
Oh yeah, it is so exciting. Thank you so much, Chris.
It's also addictive, as we all know.
So Chris, I made a note of something you mentioned earlier. You said everything is timed against this dit train.
Correct.
And I have to say, watching you go through, because when I read it the first time, the 2-to-1 wasn't obvious, and I think now it's very clear to me. And I'm wondering why. I'm wondering if the fact that things are timed against this train, this underlying metronome, is one of the reasons that newbies kind of struggle with rhythm. And I'm also wondering, so I tried just in my head to do Paris on the rhythm, and it's harder than it sounds. I dit-da, nice and easy, right? The period doubling is easy, but the complex rhythm on top of that is a bit of a challenge. And I'm wondering if that's what needs tuning or training to get people to send more rhythmically and more beautifully.
Yeah, well, I think we'll get to that in part three as well, a lot when we're talking specifically about keying, learning techniques for keying. I know that Tom, WA9CW, has talked about some of these things in his class, the idea that, as I show in here, each letter is an individual entity, an individual unit, like R is dit-Dah. You know, it is what it is. It is dit-Dah. And learning that as a rhythm and getting the point to where that rhythm is burned into your brain is what's got to happen as a part of the practice. And so that idea of sending the characters, when I say they've got to be distinct and separate, I'm kind of implying that the way you do it is that you have to send an A, boom, and then you send a B, bump, and those actions are pretty discrete that's going on in the head to get them to come out of the key right. Otherwise, you're right. But when you do that, when they're all lined up and you've got the rhythms right for each one, the rhythms will come out equal to the rhythm, to the dit-train rhythm. And yes, you're right, by the way, if you want to really drive yourself nuts, get out a metronome and try to actually do it against a metronome at high speeds. Whoa, it's tough. It's very tough to actually stay perfectly on that rhythm. More to the point is that when you get off it a little bit, knowing what the rhythm is getting back onto it, slipping right back into the rhythm as you go away from it a little bit in speed and regularity and that sort of thing, I think is pretty important. People have to learn that. But it's basically, I think, learning the clumps of characters, learning them as individual entities, lumps, as rhythms. They are, again, in the perception section, I get into the notion that perceptions are individual events. Experience is what happens when they're summed together and occur over time. The sum of events over time is experience. And we don't actually listen to Morse code, we experience it because it happens, the rhythm happens as it's a thing that happens across time. And it's not as much the sound really as it is that, because obviously you can do Morse code with light. So there's no sound involved in copying Morse code if it's light. But nonetheless, you have to copy that rhythm, that thing that happens. And that's fun too. We'll go over that, as I said, in the perception section. We'll talk about that quite some bit. Anybody else want to ask a question or throw a rock? Nothing. Well, okay.